welcome friends to this NPTEL MOOC module on exploring healthcare survey data. We are on the particular week explaining on inferential statistics in healthcare. The first lecture is on understanding regression models, specifically on the quantitative and qualitative variables and their use in models. In this particular lecture, we will be emphasizing on only on the quantitative variables. On our next lecture, it will be on qualitative variables. Again, you might be having some sort of problem with whether it is quantitative dependent variable or quantitative independent variable or qualitative dependent variable or qualitative independent variable. We will give all sort of clarifications to you, so that your understanding in this regard will be much crystallized. Without discussing the background of it, let us move on and clarify what is all about. Okay. And starting from the very first aspect of regression, as we all know that this is quite common in different statistical techniques as researchers use to answer several questions. The regression results and their analysis have various uses, especially it gives certain predictions about the value of the dependent variable based on at least one independent variable, at least with the value of one independent variable. This explains the impact of changes in an independent variable on the dependent variable. This helps in determining the strengths of relationship between these two variables x and y. Also it helps in forecasting the value of y based on the control variables or x variables. This gives cause and effect relations, though the causal inferences cannot be drawn, but certain logical understanding through the theoretical model can be mapped through the regression coefficients. And regression analysis assumes a linear relationship between the predictor and outcome variable. We need to first establish the relationship between correlation and coefficient by their definition, by usage, by which kind of variable they consider, what are the indicators, the objective, etc. Starting with the definition, correlation, we know that there exists relationship or association between two variables, whereas in case of regression this describes how an independent variable is numerically related to the dependent variable with certain logical relationship between these two. Now, you might be confused whether it gives cause and effect. In reality, it does not give perfect cause and relations or effect. It gives some understanding related to why it had happened and how it has happened, how it is relevant, but the exact causal conclusions are not derived through regression. But it is for sure how much it is affecting, what is the quantification of it can be derived from the regression. Correlation and its uses are like it gives linear relationship, whereas a perfect fit line or trend line, best fit trend line could be derived based on the variables and its relationship with another variable. But in correlation, the perfect trend line is not derived. Regarding dependent and independent variables, correlation does not differentiate these two, whereas in case of regression we have to differentiate, then only we can find out the impact of one on another one. Containing the indicators of correlation and regression, the extent to which two variables move together are called correlation, whereas in case of regression this indicates the impact of a unit change in the known variable on the estimated variable. The objective of correlation is to find a numerical value expressing the relationship between the variables, whereas in case of the regression analysis this gives estimates and their values of random variable on the basis of values of the fixed variable. We are now attaching information about about linear regressions. and their analysis, how these are read. This is most commonly used method to understand the outcome variable and the explanatory variable. Then the dependent variable must be continuous one. Okay. If it is not continuous one, then we will discuss some forms of non-linearity or some transformation to linear model that we will discuss in our successive models. At this moment we are saying that the dependent variable must be continuous. The independent variable can take any form, may be continuous, discrete, indicator type like dummy variables, etc. The linear regression model describes how the dependent variable is related to the independent variable. The relationship between the mean of the response variable and the level of the explanatory variable assumed to be approximately linear. So, that is why it is called linear regression analysis. There are different types of linear regression models. One is called simple linear regression, another is called multiple linear regression model. Simple, where we also call it as bivariate regression model, other one is called multivariate regression model. Variate means the extent of variability due to the number of factors included, number of variable factors included, independent factors included. At this moment there are only two factors, impact of x and y, but here there are so many factors. Okay. So, and so on. All right. So, that is why we have even if we are saying x is in fact a vector of information of control variables. So, beta 1 x, the equation which we have mentioned here is a kind of kind of vector of dependent and independent variables. And this equation is best explained in Green book of econometrics, okay, where the matrix method, how it is explained, how different vectors are explained in shaping up the equation like this are well explained. You can have a look and find out the exact reasoning behind writing on beta naught plus beta 1 x plus epsilon. Epsilon is the error term. We know that the x cannot explain everything about y. There must be some other component called some fixed component as explained by beta naught, and there will be still some unexplained aspects captured through the error term. So, in case of multiple linear regression, we have to discuss so many other independent variables along with the first one. So, and we can able to estimate each of their coefficient differently, and that will be helpful in interpreting the result correctly. Let us understand the structure of the model. As we know that y represents a dependent variable, beta naught is our intercept or the fixed coefficient, which is independent of the change in the covariates. And likewise we can give example of consumption as a function of income, okay, and other factors. If I writing down C as a function of income, when income tends to 0, C may not be tending towards 0. There will be some positive consumption even if income boils down to 0 for a particular consumer. The particular consumer or household may not get income in that particular month, but they are supposed to consume something by borrowing or by other means of getting the food. Therefore, consumption there must be a fixed component. Similarly, almost all the variables in the world that we are trying to project must follow this kind of structure. So, other details we have already highlighted, and I am sure this will help you. Epsilon is called the random error component, that is also called unexplained or random or error component. This term is this is called error term and or also called disturbance term, sometimes denoted by u also u, and that is in fact distributed normally with 0 and 1 standard deviation. So, this shows the normality of the distribution, so that all sort of projections in the model can be made. Okay, we will explain some of these things in this particular lecture. Population linear regression model, how it is explained. In this diagram, you can see a trend line. It is fitted with that is simply called expected y value is equal to beta naught plus beta 1 xi, and beta naught is the intercept, and any dots you could see in this particular diagram, dots like here, all dots are deviating. Some of the dots are deviating from the trend line, and the trend line is explained in the expected value given their control variables. Now, our purpose here is to identify the extent of error, the differences of each value from the standard line or from the trend line or from the fitted line. So, E, G, G is explained here, and these are also all dots explain the exact information, or they are also called observed value. We have also highlighted that observed value, how observed values are actually deviating from the predicted value of y for xi. So, if our observed value are almost on the trend line or on the predicted line, that means our estimation is actually expected to be very good. In that case, your R square is expected to be quite good. Okay. So, it will be close to close to 1. But in most of the cases, like in survey data, R square value, as we already explained earlier in our previous lectures, that it is usually lesser. So, you need not worry much. We have given all reasons behind R square and its range, which one could be read, how it should be interpreted, though this is what we already explained in our previous lecture, previous week's lecture. So, you have to follow and find out the differences. Now, here we are presenting a difference between population and sample regression model. Population, where we have written the equation yi capital yi is equal to beta naught plus beta 1 xi plus epsilon. From here a random sample is taken. That random table is going to give you a sample data, sample series of data. That series we can estimate, and those estimations are actually here are our estimated beta value. Okay, and that is going to project the population beta values, and if it is correctly projecting, then our sample is in fact giving the right result in terms of predicting the population information. This is what we usually follow in our sampling design, and the rest of the details are very much clarified from the diagram itself. Now, we are explaining sample linear regression. We have already explained the population linear regression in this chart and this table. Here it is sample linear regression. So, the population, now you can see how the unsampled observations we have we are just highlighting the sample linear regression line, or sample regression line provides an estimate of the population regression line. Okay. And and these are all going with the estimated value. Okay. These are in fact called estimated value. One hat is written, that means they are the estimated values based on the sample data we have collected. So, those hat is in fact useful in predicting the population values. Okay. So, like we take so many variety of samples, those have different distributions. In each cases, we will establish number of tests whether which sample is actually catering to the or in fact representing the population. So, whichever is estimating quite good, then our regression model is in fact predicting the population very correctly. So, sometimes we take number of different set of samples, that if each of the estimated values are not varying much, that means our estimation is in fact robust. So, those technique we do, I am not emphasizing much here. Now coming to method of estimation. There are different methods of estimation, sometimes use maximum likelihood estimation as well, but at this hour we are explaining about ordinary least square method, OLS. So, one of the methods of estimation through OLS. So, OLS is abbreviated and it is used frequently by researchers. This is in fact, as I already said, the most commonly used method, and estimated values are represented with their hat, beta naught hat or beta 1 hat. They are determined based on the error, least square error. Okay. So, now you can see the estimated value is presented here, and this is in fact each of the observed value minus the estimated value, the difference is in fact called as error. Okay. So, that is EI, epsilon I. So, epsilon I and its square is taken wherever we can minimize the errors. So, that eventually indicate our estimation is going to be fitting with the trend line. So, minimizing that error is important. Now, if you won't have taken, it might be the case that the minimum is fine, but if you do not take the square, it is very difficult to minimize the error. Like, because sometimes some values of this might be positive, some if it is not having square term, then some might be negative. The average might boils down to be 0. Okay. So, then in that case estimating or minimizing the value nearest the estimated value is in fact very difficult. So, squaring is going to give us non-negative values. Non-negative values. So, then we have options to minimize it as close to the 0 value possible. So, that is why it is called squaring the error term. Okay. So, that is why it is called least square. We are trying to understand which one is in fact giving us the least error. So, that is why this is called sum of epsilon I square, and then these are estimated like this. Okay. So, graphical illustration is given in this particular picture. There are different E1 hat, E2 hat, E3. If all these are in fact estimated and derived with the lowest levels, minimized level with their square term, is called least square error. So, next one is coefficient equations. What we mean by this coefficient? First is estimated value of EI, basically it is estimated. So, estimated value of error term is missing here, because the expected value of UI minus U bar is equal to 0, and or you can say that epsilon I minus epsilon bar is equal to 0 because of the assumption. Assumption is that our distribution is normal. Okay, since we have already said this is distributed n with 0 and sigma square. So, this is what we already said. So, when this assumption is fulfilled, that means the error term is estimated to be 0. So, whatever is left is in fact the estimated value in terms of beta naught and beta 1 hat. Okay. So, now based on this we can estimate finally the value of beta 1 hat and beta naught hat. So, you can just see further on beta how beta value is fulfilling blue properties or not, Bayes linear unbiased estimator or not. So, but this is estimated as beta 1 hat is derived as sum of square relationship between x and y, that is the covariance divided with the variance of x. Okay. So, covariance basically the relationship between y and x divided by its sum of squares of its own variance. Then once beta 1 hat is determined, then we can estimate the beta naught hat as well. So, the assumptions of linear regression model is very important, and you must take the note of it. Each of it is very important to validate your model of OLS, whether it is in fact applicable or can be applied in many contexts or not. So, first assumption is that the linear regression makes the following assumptions. They are, first one is called linearity. The relationship between the dependent and independent variable must be linear by its coefficient, not by its variables, and linear by its parameter, not by its variables. So, variables it could be of like this, y if I say it. So, it should be, if it is beta naught, then beta 1 it could be of xi square. Okay. So, and epsilon, if I take this as a modified equation, still the linearity holds, because linearity still holds with the parameters. Okay. So, we are estimating, this is explained here already, and if it is yi is equal to beta naught plus beta 1 q, then xi and epsilon, this is in fact not a linear model. Okay, not a linear model. Okay, so, this is rejected at this moment. We are not estimating a non-linear model. Next one is called non-autocorrelation. Autocorrelation, the word itself says it's having covariance between pair of random error. So, error inferior over the time, if there has been some continuity of the data. So, the errors are actually having certain path of progress. In one period there are set of errors, in second period there are again set distribution of error. There are those errors, if like error I and j, if given the control variables are x, if it is equal to 0, okay, that means covariance, there is no covariance. Okay. So, that means the error terms are considered to be having no autocorrelation. If you are having autocorrelation, this will be obviously non-zero. So, the error term has population mean 0, the error term should be normally distributed, as we already said, especially its population mean, the entire population. So, the expected value of error term given its control variable should equal to 0. All regressors are uncorrelated with the term with the error terms. So, error term should be uncorrelated. This is what we wanted to emphasize here. Next assumption is on homoscedasticity. That simply says that your variance of the error term, which we have been emphasizing, those variance must be constant. Okay, must not be varying, must not be different every time. So, it should be constant. This is what is explained with sigma square. Once it is constant, that means we are assuming we have assured ourselves that our distribution is not going to be changed much. So, our prediction is going to be better. So, as against homoscedasticity, so in that case your variance is going to be explained as sigma I square. Okay. So, I stands for some variability, and in it is different in different scatter plot. So, if you take several sample out of your population, your variance is going to be different every time. If it is not varying much near about the same value, that means that the data is in fact following OLS assumption, okay, or it is more or less normal. What about multicollinearity? Multicollinearity is basically the word says collinearity. So, how linear, collinear, that means more than one variable, the explanatory variable. How if there are multiple linearity relationship, that means we simply say multicollinearity. So, in other word, it says that there should not be any perfect linear relationship among x variable. Among the explanatory variable, if there exists some linear relationship or perfect linear relationship, then we are actually violating. Why we are violating the OLS model? OLS is not going to be efficient one, because from one beta value you wanted to predict something about the y, but in fact that beta value is not independent, it is explained by another independent variable. So, your model is not correctly estimated. Therefore, we have to assume the model with no multicollinearity. Next is about normality of the error term, where the error term is in fact distributed like this, that I have just explained. It should have 0 mean and constant variance. And next assumption is on number of observation must be greater than the number of parameter to be estimated, like beta 1, beta 2, beta 3, beta naught, etc. Number of parameters must be less than that of the observations we have considered, otherwise the OLS estimation cannot able to predict correctly. Okay. Next to guidance is on illustration of linear regression in healthcare data. For this purpose, we are using NSS 7/5 round data on healthcare for the year 2017-18. Okay. We are interested in examining the factors affecting the total health expenditure in the case of ailment or ailment persons. Some households and individual level variables are taken as explanatory variable for the analysis. One note is here for you that the purpose of this lecture is to show how to do regression analysis of using healthcare variables. It does not give the exact model used for research purposes and the required testing after regression. So, we are just giving some sample set of explanation practical results, those you may not directly use it for writing papers. So, you need to understand the concept and develop your own model. Now, here that sample variables we have filtered from the 75th round of national sample survey. The dependent variable we have considered for using the ordinary least square regression model is of medical expenditure, and medical expenditure we have transformed to a log medical expenditure. The log transformation is taken to make it more rationalizing of the data, because usually expenditure as a variable is more skewed. Okay. So, expenditure is overstated, whereas income is usually understated. So, when expenditure is overstated, a transformation log transformation is going to nullify and simplify the data to make a better distribution. Similarly, some of the relevant independent variables we have noted down, like sector dummy, rural with and its urban categories, then social groups, age square we have taken age into age, household size, household usual consumer expenditure, okay, and nature of ailment, medical insurance and their premium, nature of treatment, etc. Even you can refer some of these variables in one of the models we published. This is our paper published this year just recently in the journal in the repository of Science Direct. Okay, so clinical epidemiology and global health journal, you can just follow, and I have highlighted this on the screen. Just click on that link and I am sure you will get the exact paper for your reference. Further to this, we will also explain about the nonlinear qualitative dependent variable models in the next class, and you will understand things better. Now, we are explaining steps for running regression model. Steps are here, like we will examine first of all their statistics, the basics descriptive statistics, then we will understand them through graphically and also understand their correlation, then we will draw and interpret some regression results, then regression assumptions to be tested, whether the regression was actually drawn correctly or not. So, these 4 important steps all must mandatorily follow to write any article, research papers. Okay. So, examination of descriptive statistics, first one is on descriptive statistics. I will simultaneously open the database in front of you and then operate some of the results. Rest I will leave it at the end, I will simply leave it to you, and I am sure you can enjoy, but let me now open a database in front of you. So, I am just going to open the sample data which we have kept it for this purpose, and we will experiment with this some of the variables and to derive results. Now, what I will do, I will first go through explaining describe. Okay. Describe command, that will give you the basic description of the variable. So, I will write down desc, okay, des or describe in full, that will give us the correct result. Any variables I can just write it down. Okay. So, sector I have taken here. All right. So, now the describe I have entered with that variable. Now, this has given me information about what is the storage type of this particular variable and what is the label of this. Since label are not defined correctly, what categories it has. So, label it is not showing in detail, that we will show it later, but at this moment I will explain it differently. Similarly, coming to other command like in the describe command, once again let me explain that this lists various features of the variables to be used in the linear regression. So, by typing describe all your set of variables, maybe starting with dependent, independent, it will give you the complete list of its description. Okay. So, like here if you have two variables, one is dependent, that log medical expenditure, then second one is reimbursement of medical expenditure, then it has given which kind of storage it is and how it is presented. Okay. Variable time set and format columns indicate that all the data are in this case numeric or not, since we haven't destring it, but at this moment it is not required for you to destring. Even if the data is in string, describe table will give you result, but in case of summary it is not going to give you. We are just coming to it. Next important estimation is called summary table. So, I will straight away go to this particular one software, and now I will summarize SUM, only SUM is fine, or complete summarize of the variables. So, if I just take one variable for your reference, this is going to give you the result. Now, this has given us information that log medical expenditure, which we wanted to understand. The summarized table is going to give us information about how many observations are there, what is the mean value of the expenditure, what is the standard deviation, what is the mean and maximum value. Now, just for your clarity, I am going to going to give you another summary, which is a string data. Let it be the string data of, let it be the sector, the same sector variable which we have already done it. Now, we will summarize the sector variable here. Now, you will find the difference about string variable and non-string variable. Okay. Now, enter, you will find that this also is going to give us values, because this has already been destringed. I will give you another one, let it be this is okay. Time spent in hospitals, since this is a destring variable, this is a string variable, the summarize table is going to give us 0. How do you know that this is a string variable? Just check browse and this variable br and times hospital, the font of this one must be in red, or there is no entries at all. Or I will just do one thing, there is no observation here, just browse, we will just see which are the string variable, or browse, only browse br, okay, enter. So, now you can see which variables are in fact your string and which are is non-string or numeric or labeled numeric. I have already clarified you that the values the variables which are in red font, red color, they are string variable. Those values are in black font, they are black font, they are in fact like black font, they are called numeric values. Those who are in blue color, they are called labeled numeric. They are not exact numeric values, they are in fact labeled. Okay. So, if I just do one information like at the last, these are all our numeric values. From the beginning, I will just do one thing. I will just try to summarize one information on your screen. Religion, let it be. So, now I will go to explain religion. Here is in red font. Okay. So, now summarize religion. Okay. Now, this is going to give us 0 values. So, 0 values because this is in this is in string value. Now, if I destring and run the same command, it will give me the right result. I can destring it quickly and then I can save it. I think I have already discussed that and we will also use it several times later. Okay. So, now we will go to our PPT and stick to the requirement. Similarly, next is our understanding frequencies. Okay, tabulate, there are table, there are different commands. You will get it very correctly from my modules. So, tab is going to give you frequencies of a particular variable. Tab command you can give it and then the variable name. But if you like here, if I say tab tab, the or only ta, then any variable here, let it be same religion. Okay, enter. This is going to give me what? This is going to give me frequency and its cumulative frequencies. And tabulate is the command is also possible to operate in case of string variable. But since it is not calculating anything, once it is estimating anything, the string variable are not going to give you any result. So, now if in the place of double tab and two variables, that will be giving you the values of 2 that is frequencies cross tabulation of the variables. So, tab then two variables, let us take tab and two variables, sector and religion. Then religion. This gives us information about the cross tabulation, how rural and urban sectors are actually distributed across religion, okay, and it is clearly understood. Now, there are further sophisticated commands possible and we have already explained, I have explained all in detail in the review of command section in my previous module as well. You can just follow and find it out. We will do some new addition in this module on understanding some graphical representation, correlation. Okay. So, in order to understand the correlation or to check the relationship between variables, scatter plot helps in understanding this graphically. Now, what we will do? We will copy this command and simply run it. Okay. So, and just to show you quickly how it follows, and that is the reason why we have kept it on your screen, and I am sure you can operate on your own as well. So, we will copy this scatter, we could have entered manually, but keeping the time constant, I am only directly operating it in the screen, and this is going to give us the scatter plot. Okay. So, variables remember these are not available, we can just change it. Okay. Now it has the name has been changed. You can just check how we also find that there are some error in the variable. The variable name has been changed in our data. That is why the command was not running. You have to give the exact name by searching through the window. Now you can find out how the two variables are related, where they are concentrating, what is in fact the trend line. All those things we are going to explain in this model. Then next I am going to operate with we can also operate two-way table as well, two-way scatter plot as well. Then the average could be also run. We are not going to do it at this moment. We will simply skip it, and that is kept for your reference only. Okay. Like here you can do, like you can combine scatter with to show the scatter plot. Okay. With fitted values. Okay. So the fitted values can also be explained. So that command we have already given for your reference. I am sure that trend line, the result will look like this, and the trend line, basically the fitted line command, if you attach, it will give you this kind of result. So fitted line, in this case it seems that the fitted line is not that correct. Okay. So you have to include multiple variables, the relevant variables, to draw the fitted line. Similarly, correlation can also be checked through this command. We am just going to run it as per this one. Okay. So it is here. I am just copying it once again, and we will go to that particular page, and we have kept all those things for your reference. Yes, this is the one. We are just copying it and running it on the window. Window is here. Okay. All right. So the correlation and the significance value, basically power of the correlation we have estimated. So the star mark represents the level of significance at 5% level. 0.045 command is attached with a star. So wherever the relationship is established at 5% significance level, it indicates the star mark. Okay. So start mark you can just see, I am just explaining once again. So similarly, multiple linear regression, in case of for the multiple linear regression, we can also understand the power of the correlation, basically the level of significance. So you need to just attach this part. Okay. In addition to that, comma followed by comma, then star with the bracket at 0.5% etc. If you give it, then it will give you the right result. So plus and minus sign indicates the value and their relationship, whether positive related or negative related. Higher value of row represents stronger relationship or weaker relationship. Then next check is on normality of the y variable, the dependent variable, how it is normal, what extent we emphasize about the normality of the distribution. The command we usually follow to go for an histogram, how the histogram looks like, just to check histogram log medical expenditure, which the variable we have taken, that we can do it once again. It is here. So we will run this command, histogram log medical expenditure, that has been already taken. So the histogram will be displayed on your screen. Now in this one you can easily see how the trend line looks like. The line we can also draw it through next command. This is the one. So histogram, then we will specify it. Okay, so it is here, and it will specify the graph correctly. Okay. The graph now it will, you can identify whether the graph is approximating a normal distribution or not. This seems that this is a kind of elliptic diagram, and then more it is symmetric. Okay. Though not mesocotic, so it is elliptic, but it has normality assumptions fulfilled. Okay, so then coming to the next one, this is what we have already explained. So, this is what we have derived. Then another one is called kernel density plot. Through that you can also check the normality of the distribution. This is an alternative way to check the plots. Okay, so this also gives approximate values of the probability density function of the particular variable. So, here we need to specify k density, the variable name, then normal the word we need to mention. Kernel density plots have the advantage of being smooth and of being independent of the choice of origin, like histograms. Okay, so this will look like this. I am not going to draw it here once again. So, you can see how the normal distribution plot is derived. Kernel distribution and estimation is highlighted with the blue line. This is almost overlapping with the normal density function. Here you can easily say that yes, your data is more normal. Next one is about model estimation. Beginning with simple linear regression, in which we only have one predicted variable. In Stata, the dependent variable is listed immediately after the regress command. Regress is the command we give. So, the dependent variable will quickly follow the regress command, then one or more predictor variables to be specified. It is like this. This is one. This is our dependent variable. Then all sort of independent variable could be mentioned. All right. So, this is what is going to give us the estimation. Okay. So, first of all we will copy this, then if I remember this variable, we can simply click that log medical expenditure, then reimbursement, then medical insurance, etc. So, we will straight away go to Stata, we will type regress. Okay. So, then all the variables are listed here. Log medical expenditure we are taking as the dependent variable, then we will take reimbursement, then related to reimbursement of insurance. Okay. Insurance reimbursement for the medical expenditure. Now, on the screen you have got your got your regression result, the ordinary least square regression model. This suggests that how the coefficient beta value and beta naught and beta 1, the constant is in fact is your beta naught, that is 6.019169, and your beta 1 is 0.00022226. Most importantly, we need to understand whether the data the coefficient is actually significantly estimating a model or not. Now, p values is very effective. P value, if it is less than 0.05, that means it is significant at 5% level. If it is less than 0.01, that means it is significant at 1% level. So, here it seems that your beta value is significant at even 1% level as well. So, I am just explaining through the diagram through the PPT. Here are the results. Many interpretation you can do it. First, you need to check about the entire model, whether it is significant or not through the F test. By default, it consider the F test, comparing the differences of residuals. Okay. So, F test is defined, and the degrees of freedom are more important. So, F test values and its degrees of freedom are its numerator and denominator are 1 and 14942. This is given, and because number of observations are 14,944. Okay, and accordingly others are understood. Now, the fitted line for log medical expenditure is in fact that we can derive. Now, at this moment let me just clarify its p values, which I have just said is given here. Okay. The model says that regarding whether it has a perfect fitted line or not, R square value which we explained earlier, R square and adjusted R square value are important. R square suggested that around 1.2% of the variance in medical expenditure is explained by the reimbursement by medical insurance. So, similarly adjusted R square where the degrees of freedom due to the parameter are changed. So, number of estimated parameters are changed. So, accordingly, since here only one parameter we have taken, one independent variable we have taken. So, number of parameters are the same as per the entire model. So, R square and adjusted R square are same. Okay. So, it is not different. When you increase number of more than one independent variable, your degrees of freedom will be different, and adjusted R square value will be lesser than that of the R square value. Okay. Adjusted R square value could be also negative, which all those things we already explained. Another information in this chart around about ordinary linear regression is on root means sum of square. Okay. That is root mean square error. Okay. So, root mean square error is in fact the standard deviation of the regression. This is the closer to 0 better the fit. Okay. And from all those things we can estimate a fitted line. So, fitted line for log medical expenditure is equal to anti-log that is of 6.02 of the constant variable plus 0.0002 times the variable that is reimbursed by medical insurance. If I do this calculation, I can get a fitted line. This is what your Excel or even your software usually follow to derive the fitted trend line. Similarly, we can do a multiple linear regression by adding another variable. Here we have added in addition to this insurance, we have added now square edge. Okay. So, with the same regress command, we have got the information. All those are very important, number of observations, F values, whether the model is significant or not, R square, adjusted R square, root mean square, we have already all explained. Okay. So, similarly residual sum of square, total sum of square, so you can also estimate t values, then p values. Okay. Okay. So, and their coefficient, everything is presented. So, I have already explained, I think I need not spend more time here. The above results include only continuous variables as explanatory variable. We can also include indicator variables into the model with little caution if there are certain indicator variable or dummy variable. The easiest way to include a set of dummies in a regression is by using the prefix I. If there are set of dummies are included or indicator variable included, I dot command is most suggested, that will be comparing your categorical variable from a base category. By default, the first category is considered as the reference category. In that case, some conditioning should be given. So, putting xi should be there, xi command along with the regress must be there, and that will give you better information related to the interpretation of the dummy variables. So, this is how the command looks like. In our next module, we will explain all those things in detail, but at this moment we are not drawing. I will interpret the result to some extent. If I give xi along with regress, I am doing it because I have some categorical variables like sector. So, I dot is taken, then another categorical variable is here social groups, education, etc. Similarly, here as well. So, this will compare its base category, like if sector we have rural and urban. Okay, rural is our base category and urban is another category. So, the coefficient whatever we have received, rural by default is the base category, you can also change the base category. Your coefficient is going to interpret it as how urban is comparatively better off or incurring expenditure as compared to rural on the medical expenses. Okay. So, in that case, another interesting aspect is to control for heteroscedasticity in the model. You can also include robust option. Okay. So, robust option is going to control your heteroscedasticity. it will give unbiased standard errors of OLS coefficients under heteroscedasticity. So, there are some other details like standardized coefficient, unstandardized coefficient. Since we have already run for huge minutes in this lecture, we are not spending much time. I am just wrapping up all those things detail. In our next episode, maybe in the next year, we will come up with detailed lecture of all those things. Okay. At this moment, I am just clarifying this concept of what do you mean by standardized coefficient, what do you mean by unstandardized coefficient. Regression equation for standardized regression coefficients is simply unstandardized regression coefficient is simply taking its variable as it is, okay, x1, x2, etc. So, beta 1, beta 2 are called unstandardized coefficients. Regression equation for standardized regression coefficients, if anything any other variables are standardized, like if beta 1 is not just with its xi, rather xi is taken from their mean value divided by the standard deviation. That means, the x variable xi variable has been standardized, x1 variable has been standardized, here also x2 variable has been standardized. The coefficient that we derive, that is beta 2 star and beta 1 star, are actually called standardized coefficients. Okay. And there is no beta naught because if you standardize that, since it is already a constant, and if you take its mean value from its constant value, that means mean and the value itself are same. So, the difference is going to be 0. So, there will be no question of beta naught. Okay. Therefore, when we have a standardized coefficients, beta 1 star is equal to beta 1 times standard deviation of x1 divided by standard deviation of the dependent variable. So, this is very important so far as any quiz question is concerned. You can just take note and you will understand further. To get the standardized coefficient, include beta option in the end of the command. So, the beta if you are just by adding comma then followed by beta coefficient is going to give you standardized coefficient value. Rest of the commands are same. Okay. I am not calculating step by step. We will certainly come up with this in the next episode. At this moment, we are just clarifying it. Standardized and non-standardized coefficient, by definition, by interpretation, how it is misleaded, how these are regarded in case of binary variables. All those things I am sure if you read you can able to enjoy and understand the difference between unstandardized beta and standardized beta. Okay. I am not going through in detail, these are all explained, the basic meaning I have already explained. I am sure you will understand this. Some points to consider while fitting or estimating model, like fit the maximal model, begin simplifying the model, etc. can be done. Like the maximal model is the large model that contains all the explanatory variables of interest as predictors. Okay, that is called maximal model. This model also contains all the covariates that might be of interest. It also explains or it also contains all the interactions that might be of interest. Note the amount of variation explained is also captured correctly. Then begin simplifying the model, inspect each of the terms in maximal model with the goal of removing the predictor, that is this least significant one, then drop those from the model and those are least significant, and then further you run the regression. Now, feed the reduced model, compare the amount of variation explained by the reduced model with the amount of variation explained by the maximal model. Okay, so the strategy to keep or drop variables is like predictor not significant and has the highest expected sign. In that case you can keep the command we have already said, keep or drop command, that you can drop or keep and then further review and find out which one is in fact your better model. Then you can actually also predict. By predicting you have to give the variable command as predict, then that variable with a heart is there. Okay. How good the model is dependent on how well it predicts, the linearity of the model and the behavior of the residuals, etc. Generating predicted values of log medical expenditure. After running regression, simply you give predict at the command. So, basically whatever the result we have got, that is in terms of hat. Okay. By hat, it should save it as by adding with a hat, in addition to that name. Then predict R and recid, that will give you the distribution of his residual terms. Okay. Checking model assumption and fitting, how clearly these are going to give it. I think we can do it shortly, but I am not going to explain these things in detail. I am just explaining the overview of it. Okay. So, checking whether the model assumptions are fit or not, we have already started with some model called graph. If you go by graph, two-way scatter plot, of all those things, that will give you a graph. Okay. So, graph, then the fitted line can also be derived. That fitted line, if it is perfectly going with the distribution, then your model is fine. Here it seems your model is not perfectly fit. Similarly, normality in residuals, I already told you one command called k density, but in this case p norm and q norm to be given to check whether they are following normal distribution or not. Okay. So, then k density and normal, if you do it, it will be plotting like this, and accordingly we can understand. Similarly, standardized normal probability plot, that is p norm, checks for non-normality in the middle range of residuals. In that case, p norm r, then you can give title of that particular chart with the bracket about the normality, normal check, it will give you information. Some other assumptions check is through multicollinearity. We will explain in our other models as well. But at this moment, if you go by the statistics books called VIF, variance inflation factor, mean VIF value should be less than 10. Okay. If it is greater than 10, then there will be multicollinearity. So, the mean VIF value is here. If it is very less, that means your model is perfectly fine. So, VIF command, it is important, VIF, that will give you the result like this. Okay. I am not drawing it, we will draw it sometimes in our other modules. Similarly, testing for homoscedasticity, usually we go for Bruce-Pagan test. Okay. So, that is basically detects heteroscedasticity in the model. The null hypothesis is that the results are homoscedastic. That means they are having constant variance. So, that command is called E-start head test. E-start head test. My previous module on large scale data handling, we have also included this. If you want further reading, you can also refer that as well. But otherwise, you simply run with this command, you will get this kind of information. Our assumption is that our residuals are homoscedastic. There is no variation in the residuals. The standard deviation is constant, but here it seems that your result is significant. The assumption is constant variance, that means it is deviating, it is actually rejecting your assumption. So, that means there is heteroscedasticity. So, this is what is interpreted, and rest you can just read between the line, and I am sure you will enjoy reading. And this is a very big lecture, and we have skipped some of the section deliberately, and I know that if you go through, you will have lots of queries, and we will be happy to deal with it in our live session class. Okay. So, with this, I think it is time to close, and I look forward to your queries. Thank you.